Beneath the vast emptiness of space, beyond the reach of our warm, sunlit Earth, lie worlds that seem frozen, lifeless, and silent. They drift in darkness, their surfaces locked in ice so thick and ancient that sunlight has never touched the waters below. At first glance, they look like dead worlds. But science has a habit of revealing secrets to those who look closely, and what we've found beneath these alien glaciers may change everything we know about life in the universe. Take Europa, one of Jupiter's largest moons. From space, it appears as a pale, cracked marble, its surface etched with long reddish-brown lines, like veins in some cosmic ice sculpture. Those lines are more than scars. They are signs of movement, of something shifting deep below. Scientists suspect they are evidence of tides, not tides pulled by wind or waves, but tides in a hidden ocean buried under kilometers of ice. An ocean that, despite the cold of deep space, could be warm enough to keep water liquid. And if there's liquid water, there might be something living in it. Imagine standing on Europa's surface. The ground beneath your feet is ice as hard as stone, stretching in all directions under a dim, distant Sunday. The airless silence is total, broken only by the faint creak of ice as the moon flexes from Jupiter's gravity. You wouldn't know it, but far below you, deeper than the tallest mountains on Earth, is an ocean so vast it could hold twice the amount of water as all of Earth's seas combined. And somewhere down there, in that lightless abyss, something could be moving. How can such an ocean even exist in a place so far from the sun's warmth? The answer lies in gravity's invisible grip. Europa is locked in a delicate dance with Jupiter and its neighboring moons, a gravitational tug-of-war that stretches and squeezes its interior. This constant flexing generates heat through friction, the same way bending a paperclip back and forth makes it warm. That heat rises into the icy crust, keeping the water below from freezing solid. The process is slow, relentless, and it may have been going on for billions of years, long enough for life to begin. We've never drilled through Europa's shell, but we've caught glimpses of what might be happening below. Spacecraft like Galileo and Hubble have detected plumes of water vapor erupting into space from cracks in the surface, as if the ocean is trying to breathe. These geysers shoot hundreds of kilometers into the vacuum, carrying with them the chemistry of the deep. Some scientists believe they may even contain biological material, traces of living things from a hidden ecosystem. But the truth is, we've never caught one up close. Yet, and Europa is not alone in its mystery. Around Saturn, there's another world that has stolen the attention of planetary scientists. Enceladus, smaller than Europa, and icy white like a snowball drifting through the black. Enceladus seemed ordinary until NASA's Cassini spacecraft flew past it in 2005. What it saw changed our understanding forever. Jets of water vapor and ice particles were blasting out from Enceladus's south pole, forming a shimmering plume that stretched into space. Cassini flew directly through it, tasting its contents with onboard instruments. What it found was astonishing salty water, complex organic molecules, and tiny grains of silica that could only form in hot hydrothermal vents. It was as if Enceladus were hiding a miniature version of Earth's deep-sea vents, where life thrives without sunlight. But what could be living in such an alien ocean? Somewhere under that icy crust, heated by the friction of tidal forces and perhaps even radioactive decay, Enceladus's ocean might be circulating like the great conveyor belts of Earth's seas. And just like our oceans, it may be a cradle for life. Perhaps not life as we know it, but life all the same. The thought of it is both humbling and unsettling, because if life can arise here, it might be everywhere. Yet for all our curiosity, These worlds remain locked away, their secrets guarded by kilometers of solid ice. Reaching those hidden oceans is one of the greatest technical challenges in planetary exploration. Drilling would require machines unlike any we've ever built. Robots that can survive crushing cold, high radiation, and months or years of tunneling through frozen crust. But scientists are determined, because they know what might be waiting beneath could answer one of humanity's oldest questions. And there's another reason we search. These oceans might not be as silent as we imagine. When scientists say these alien oceans might not be silent, they aren't speaking poetically. They mean it in the most literal sense. On Earth, sound travels through water faster than through air, and in the deep, it carries for great distances. Hydrothermal vents roar with a steady rush. Shifting ice groans as it flexes, and creatures communicate in clicks, pulses, and low rumbles. If Europa or Enceladus hides life, then somewhere far below the ice, the darkness might be alive with sound. And that sound may not be entirely natural. We've detected no such noises yet, but the technology to listen through kilometers of ice is still in its infancy. If we ever succeed in dropping a probe into those black waters, the first moments could be filled with quiet suspense, until a distant, echoing sound drifts in from the abyss. A sound that could be nothing, or everything. But even more intriguing is the question of how life, if it exists there, could survive in such extreme isolation. Here on Earth, deep-sea creatures live without sunlight, relying on the heat and chemistry of hydrothermal vents. Giant tube worms, blind shrimp, and pale crabs flourish in total darkness, feeding on bacteria that turn chemicals into energy. If similar vents exist beneath Europa or Enceladus, they could provide the same kind of refuge. But on these moons, the isolation is complete, cut off from the sun for billions of years. Whatever lives there would have evolved in a world no human has ever seen, and we might not even recognize it as life. This is why every new mission to these icy worlds feels like a step toward the unknown. NASA's upcoming Europa Clipper will fly close to Europa dozens of times, mapping its surface, studying its chemistry, and searching for signs of water plumes. Each flyby will collect clues, subtle temperature changes, strange magnetic patterns, or chemical fingerprints in the thin atmosphere. These clues may point toward an ocean teeming with activity, or toward something stranger still. Meanwhile, the European Space Agency's JUICE mission is on its way to explore Jupiter's icy moons, including Ganymede, a moon even larger than Mercury, and one that may also have a buried ocean. Ganymede's magnetic field hints at a deep, salty sea beneath its shell. If confirmed, that would make 3 ocean worlds circling Jupiter alone. The odds begin to shift, suggesting that watery moons might not be rare exceptions, but common features in the outer solar system. And the more common they are, the more likely it is that one of them isn't empty. But our curiosity doesn't end in our own backyard. Farther out, beyond Saturn's realm, lies Pluto, once called a planet, now a dwarf world at the edge of the sun's influence. For decades we imagined it as a frozen rock, locked in unchanging cold. Then in 2015, NASA's New Horizons spacecraft flew past, revealing a world of unexpected complexity. Mountains of water ice, glaciers of nitrogen, and hints of a subsurface ocean kept alive by internal heat. Even here, at the dim edge of our solar system, liquid water might be hiding. And if it's hiding there, where else might it be? Astronomers have even begun to suspect that the galaxy is filled with rogue planets, worlds that drift in darkness without a star. If some of these carry thick ice shells, Tidal heating or radioactive decay could keep oceans warm beneath the surface. Imagine it. Entire seas floating through interstellar space, cut off from starlight for eons, yet perhaps still alive. We may be surrounded by more oceans than we ever dreamed. Oceans we'll never see directly, but that might, at this very moment, be holding their own quiet secrets. And that leads us to the most unsettling possibility of all. If life exists in even one of these hidden oceans, it may have been evolving for far longer than life on Earth. On Earth, life began at least 3.5 billion years ago, and perhaps earlier. That's an immense span of time for evolution to craft complexity from simplicity. But if a hidden ocean on Europa, Enceladus, or some other ice-covered world has been liquid for even longer, then evolution there may have followed its own path entirely. Creatures in such a place would have no need for eyes, no concept of light or sky, and perhaps no form we'd recognize. Yet they might have senses we cannot imagine. And if they have, they've had eons to perfect them. This idea raises a haunting question. If we were to meet such beings, would we even understand what they were? We might send instruments to measure heat, chemicals, or motion. But what if their form of life uses an energy we don't yet comprehend? What if the signals they send are not in light or sound, but in ways invisible to us? We might pass them by, not realizing we had brushed against the alien. And the thought of what we might miss is enough to keep scientists awake at night. That's why missions to these ocean worlds are designed to search for broad signs of habitability, not just for life as we know it. We look for heat, chemistry, liquid water, and energy sources because those ingredients seem to spark biology on Earth. But the more we learn about extreme environments here at home, acidic lakes, boiling springs, deep crustal rocks, the more we realize life finds a way in places we once thought impossible. And if it can happen here, could happen out there too. In fact, it might already have. The Cassini spacecraft, before ending its mission, detected molecular hydrogen in Enceladus's plumes, a gas that on Earth often comes from hydrothermal activity. In our oceans, hydrogen is food for microbes at deep-sea vents, forming the base of entire ecosystems. On Enceladus, it might serve the same role. That means a moon just 500 kilometers wide could be home to one of the most important discoveries in history. And we may already have flown through its evidence without even knowing for sure. Yet the cruel reality is that confirming life will not be easy. Collecting samples from a distant moon, bringing them back, and studying them in laboratories could take decades. Even if we find something moving in the dark waters, proving it's alive, and not just a chemical trick, will demand certainty beyond doubt. Until then, the oceans will remain what they are now. Silent, sealed, and waiting for us to knock on their icy doors. But perhaps, in some way, they already know we're here. It's strange to think that in the coldest corners of our solar system, warmth may exist not because of sunlight, but because of the pull and squeeze of distant giants. And stranger still to imagine that in those hidden seas, something might already be watching, listening, or drifting through the currents, unaware of the frozen ceiling that separates its world from ours. To them, the ice above might seem infinite, unbreakable, eternal. They could have no idea that on the other side, another kind of ocean exists, an ocean of stars. If these beings exist, they have never seen a sky. They have never known what a galaxy looks like or what it means to orbit a star. They have lived in darkness for as long as their species has existed, perhaps never needing to question what lies beyond. Yet now, as our technology reaches farther and deeper, the boundary between their world and ours is shrinking. One day we may finally pierce that shell, and on that day, the first contact will not be with another planet's surface, but with an alien ocean's embrace. But there's an irony in this. We've spent centuries pointing our telescopes at the stars, chasing distant exoplanets and faraway galaxies, when one of the most promising places to find life might be right here in our solar system, quietly circling a gas giant or drifting beyond Saturn's rings. If the universe is hiding secrets, it may be that some of the most profound are just a few 100 million kilometers away. And when we finally reach them, what we discover could reshape not just science, but our very place in the cosmos. Until then, all we can do is prepare. We can design the probes, test the instruments, and plan the missions. But perhaps more importantly, we can keep the question alive, because curiosity is the fuel that drives exploration. Every mystery begins as a what if, and every what if has the potential to change everything. The oceans beneath the ice are not just places we want to reach. They are reminders of how much we still don't know. And it's in that unknown that discovery waits. If you've enjoyed drifting through this quiet journey into the hidden oceans of alien worlds, I invite you to stay with us for more. Here on the Sleepy Minds, we explore the vast and the microscopic, the known and the unknown, always with curiosity, always with calm. Subscribe so you can join us the moment we dive into our next mystery. And if you found tonight's voyage as fascinating as I did, a like helps us keep charting these unlit seas. After all, there's still so much left beneath the surface, because somewhere, right now, under kilometers of frozen silence, something may be moving.